Hi everyone, my name is Nicole.
And my name is Matthew, and today we are going to talk about scientific revolutions.
Thomas Kuhn conceived the idea of scientific revolutions.
Yes, and he specified different phases of science in his book, The Structure of Scientific Revolutions.
Kuhn also explained how these periods in science are dictated by how scientists regard the integrity of the paradigm. So Matthew, how would Kuhn describe what a scientific revolution is?
Kuhn illustrated that a scientific revolution is where there is a shift in the scientific paradigm.
How do you know when there is a shift in the paradigm?
Well, Nicole, Kuhn characterized scientific revolutions as being a dramatic shift, one where the majority of the scientific community has agreed upon. Okay, Nicole, let's go focus on scientific paradigms, since scientists look at them as the basis of whether a scientific revolution will occur.
Good idea, Matthew. So a scientific paradigm is composed of a collection of theories, concepts, relevant tools, and methods.
A scientific paradigm also encompasses having acceptable range of answers, different schemes of interpretation, and recognition of past achievements.
So essentially, we use the paradigm as a foundation to solve issues and answer questions.
Exactly, and its purpose is to guide the community. Without it, during the pre-paradigmatic phase, people were constantly starting from scratch.
I can see how we need this kind of thinking, because without the basis of having a scientific paradigm, raw facts can't exactly interpret them themselves.
Yeah, that is why a scientific paradigm calls for having a range of acceptable answers, because it is required to make assumptions for the facts and observations given. Given a scientific paradigm, it can dramatically influence what kind of questions are asked, whether it is on the macro or micro scale.
So, in summary, scientific paradigms can help scientists guide their thinking and research. So, what are the significance of scientific revolutions?
Well, if we contrast the ideas of Popper versus Kuhn, we see that Popper postulated that science progresses through falsification. So he noticed that the more a theory forbids, the better it is. However, Kuhn believed that science developed through phases, where there are periods of normal science, then crisis, which eventually calls for a scientific revolution.
So, what are the stages of science according to Kuhn?
That is a good question, Nicole. At first, we see that scientists are operating in a period of normal science, where they were working within the established paradigm. We will get more into that category later.
So, in a period of normal science, does that mean that all the findings are abiding by the paradigm?
Not exactly. Anomalies can occur during normal science, but when it gets to a point where the paradigm is no longer wide enough to account for the several anomalies, it will lead to the next phase.
What is the next phase?
Well, now scientists are in a period of crisis, which is what catalyzes a scientific revolution.
What determines what phase scientists are in?
Well, we have to examine the integrity of the paradigm. If the integrity of the paradigm is in question, we are in crisis. And if the integrity of the paradigm is being rewritten or changed, then we find ourselves in a scientific revolution. So, Nicole, let's go into depth about normal science.
Okay, Matthew. So you explained earlier that normal science is a period where progress is being made within the paradigm.
Yes, and during a period of normal science, scientists determine facts and match them with theory. Then they articulate the theory by accounting for the anomalies that arise.
I thought an anomaly is a discrepancy that calls for a scientific revolution, because when an anomaly occurs, it means that there's a problem within the paradigm.
Well, Nicole, that is true, but there can be anomalies in a period of normal science until the community decides that the paradigm can no longer be expanded to explain the anomalies that arise. Let's talk more about the definition and significance of anomalies.
Okay, Matthew.
An anomaly is a problem within a paradigm that scientists are unable to solve. An anomaly consists of multiple discrepancies, not just one, which has several scientists test it, and the community has agreed that the discrepancies constitute an anomaly within the existing paradigm. In this scenario, the paradigm cannot explain something, and it violates rules within the paradigm.
So how common are anomalies?
They are very common, and in fact, Kuhn agreed that they are expected because not everything can always be explained by the existing paradigm. As long as there is a foreseeable future in which the anomalies can be explained or solved, then the anomalies do not necessarily have to lead to a period of crisis.
So then what does lead to a crisis?
Scientists enter a state of crisis when scientists begin to question the integrity of the existing paradigm. This doubt comes from the culmination of numerous anomalies that the paradigm cannot explain. In a crisis, scientists begin thinking critically of the existing paradigm, and some might even begin to form their own paradigms that answer the anomalies that the previous paradigm could not resolve.
Okay, so what is an example of a scientific revolution that has occurred in history?
One of the great paradigmatic shifts in human history was the realization that the Earth rotated around the Sun. This discovery was brought forth by Nicholas Copernicus in 1543. This shift resulted in the adoption of this new theory and the abandonment of the previous paradigm of the Sun revolving around the Earth. Another great scientific revolution was Darwin's Origin of Species and theory of natural selection. This scientific revolution resulted in a change in our understanding of humanity's origins. This revolution provided a scientific explanation to where humans came from and resulted in the abandonment of the previous religious paradigm. Well, Nicole, I think that wraps this up.
Yeah, Matthew, I learned so much more about scientific revolutions than I knew before.
I hope our audience can say the same as well.
I'm sure they would.
Thanks for watching, everybody.